We have 250 milliliters of a 0.15 molar acetic acid and a 0.25 molar sodium acetate solution. Do we need to add acid or base to change the pH to 5.55? How many moles of acid or base do we need to add? And if we know the concentration of the acid or base we have is 1.5, how many milliliters do we need to add? Well, the first thing we need to do is solve for the initial pH of the buffer solution. We can use the Henderson Hasselbalch equation to do that. Knowing the initial base concentration and the initial acid concentration. In this case, we're given Ka, so we just take the negative log of that in order to get pKa, plug in our base and our acid concentrations. We have a pH of 4.967. So in order to achieve a pH of 5.55, which is higher than this, the only way to increase pH is to add a base. When we add the base, we are going to decrease the weak acid concentration, the acetate concentration. We're going to decrease the weak acid, the acetic acid concentration, but increase the weak base, the acetate concentration. Again, because both are in the same solution, the volumes are the same, and we can use the Henderson Hasselbalch equation as a ratio of moles, which is going to be very helpful in this problem as it was with the previous problem. So the pH that is desired is 5.55 plus the pKa, is equal to the pKa plus the log of the moles of acetate after the addition of the strong base divided by the moles of acetic acid after the addition of strong base. This right here is the initial moles of acetate. This is the moles of base that we add, increasing the moles of weak base up top. This is the initial moles of acetic acid. Then we're going to decrease the moles of acetic acid by the moles of base added. We then get one equation and one unknown. We simply need to remember our algebra to rearrange the equation and then isolate our x value and solve for x. We need 0.02396 moles of base. Because the concentration is 1.5 molar, we can then convert the moles into liters by dividing by the molarity, giving us liters, and then convert the liters into milliliters. We would need 16 milliliters of this strong base.